Hi, for students, now come to the mole ratio questions in the equation. Then, according to this example, 12.11, I would like to highlight that the equation actually only tells you, okay, the equation only tells you about the ratio. Okay, it means this one, it when we have one Fe2O3 and then it would react with 3CO and then provide 2 Fe and then 3 CO2. It is a function of a balanced chemical equation. So this number is very important. 1, 3, 2, 3. So if I do not know, if I just say that, oh, I have 3 CO molecules, what do you expect the number of molecules will be formed, number of CO2 molecule will be formed? So according to this equation, you will know that 3 molecules. If we have 3 molecules, then I would form 3 CO2 molecules. Okay. Then if I have 10 C2O3, then what do you expect the number of Fe would be formed? You would expect we would have formed 20 Fe will be formed. 20 atoms, 20 Fe will be formed. Then because we are always provided with the mass, then we have to change it into a number of mole, because when doing reaction we are working on the number instead of the mass. So number is very important. Then sometimes you will see that excess means you can ignore how much it is provided, because it is you can think that the supply has no limit. So in excess will be a lot. So the amount is not important. Then I would recommend you the method 1, but I know that if you have very good maths, you would prefer method 2. Both correct, both are allowed. But some students may go to their own way to do the mole ratio equation. I do not recommend it because it seems like very complicated. The marker may not understand what you are doing, so try not take the risk. Try to just simply show that you can use the ratio to do the calculation. So here the practice 12.8 calculate the mass of because you are provided with sentence, so you have to understand what it is provided. When we check the questions, we would first find the number, okay, provided, the data provided. 45.3 grams sulfur dioxide, so this one, 45.3 grams sulfur dioxide, and then excess oxygen. So it means that oxygen, you just ignore it. It is not important to our calculation. Then you have to check the mass of sulfur trioxide. So it means that here you can just ignore O2. O2 is not important here. So you just find the ratio between SO2 and SO3, the mole ratio. The mole ratio between SO2 and SO3 according to this equation is 2 to 2. And then we should have simplest ratio, so 1 to 1. So it means that how many mole, x mole, I can say that x mole SO2, it will produce x mole SO3. So it is the basic concept. And then now you are provided with 45.3 gram. Then you have to convert it to number of mole in order to get the answer. Oh, sorry, no, it's not the answer yet. In order to get the number of mole of SO2, SO3, and then you have to, because the answer is to give the mass, so then you have to do the final calculations to give the mass of sulfur trioxide as the answer. Then here, number of mole of SO2. Some of you are misled by the formula, by the balance equation. You will think that 2 should be added. I feel sorry. 2 here is only tells you the ratio. You just have to consider SO2, because you can think about before, when we are working on the molar mass, we just said a CO2, H2O. We never will ask you, the number of mole of 3 H2O, the molar mass of 5 CO2. No. So you just ignore the number in front of the chemical formula of the substance. SO2, so 0.707, and then I have to remark this one, these two. They are very important. You have to tell me that the mole ratio, or according to the equation, 2 mole SO2 would make 2 mole SO3, or you can say that 1 mole, or you can say that 1 mole SO2 would give 1 mole SO3, because it is the basic ratio. So this one really important. And then IE, it means therefore the number of mole made would be just equal. Okay, they have the same amount. Same number. So 0.707. And then you got the number of SO3, then you can just multiply the number with molar mass, then you can obtain the answer. So most of you got it right. And then we do not elaborate method 2. And then question 2, it gives you 2 challenges. It will be this one, 78%. You can work it at the last step. And then 15 tons. And then here it tells you that 1 tons means 10 to the power 6. So it means that here we would have 15 times 10 to the power 6 gram lead Pb. Then we have PbO, and then we have PbO. What is the mass? And then actually extract Pb, and it will give out O2. Then PbO2 will be 2 Pb. 2 PbO will give out 2 Pb and 1 O2. So the mole ratio between here Pb and which one you need to calculate will be mass of the sample. Okay, mass of the sample would be linked to PbO. It asks you to calculate the mass of the sample. And then in this sample, we have only 78% will be PbO. So we have to link them together. Oh, so I feel sorry, I should not use the same color. We can make use of these data and then to calculate this one. Yeah. Okay. We have to calculate how many mole of PP here, and then because of their ratio is 2 to 2, it means that 1 to 1, then we can obtain how many number of mole, and then to do the following step here. I have the number of mole here, and then this statement, very important. According to the ratio, 1 mole PBO will give out 1 mole PB. So the number of mole will be 72 and 400 mole. Then the mass of PBO will be this one. And then because the mass of the sample times 78% would be this answer. So when we put together, then we can get the answer will be 20.8 times 10 to the power 6 gram. Okay, either one. Okay, then method 2 we skip it. Then question 3. Question 3 here is nothing special, so I do not highlight here.